Good evening.
Ladies and gentlemen, now we invite all of you to enjoy our plenary speaker, Professor Dr. Mohamed Mohamed, Principal Technical Specialist, Imperial Technologies Ltd, United Kingdom, UK, Professor at Faculty of Engineering, Helwan University, Egypt. The keynote will be on bridging the gap between academic research and industry.
Well, thank you so much. Good evening, all. I would like first to thank Dr.Nouby and Dr. Gamal and all the committee organizing of the conference for inviting me to give a plenary lecture. I'm always happy to attend such kind of events in my loved country, Egypt. And it's my privilege to contribute some knowledge as a tech transfer, for example, from what I have got as an experience from my work in UK. Yeah, I'm very keen to do something maybe useful and some good information. So today I choose this topic. It's called Bridging the Gap Between the Academic Research and Industry. Let me to introduce myself first. I'm Mohamed Mohamed. As Dr. Ahmed introduced, I'm a Principal Technical Specialist at Imperial Technologies. Imperial Technologies is a spin-off company from Imperial College London. It is established based on the research. I was a key member to develop a new process for forming aluminium alloys for automotive and aerospace application. So I finished my PhD in 2010. I started in 2007 and I finished 2010 at Imperial College London. Is a new process. It was the first PhD in this process. And then I started the journey to transfer the research outcomes to a real application. So the university system in UK is very keen that any research has a reason to be carried out and has impact in the community and the industrial application. No research can be just put it in a shelf. No. So but the main point is how the supervisor or the researcher in Imperial College aware about problems. Because when you talk about a novel process, developing a new techniques, new process, new product, new surface, so she should be has a reason to do this, solving a problem. How do you know the problem? And how to starting their research from this problem to solve this problem and systematically use the outcome of the research to be applied outside of the university, in the public domain. So this is the main topic. I starting the journey from beginning. This is the reason I'm quite passionate about this. This is the journey from starting from A to Z. When I starting in a desk in the college, and we started to know the process, what is the problem, and how to solve the problem, and then testing the material, determine the forming window conditions, and then step by step we try to get it done and apply a small part, and then until reach to a real scale commercial part for automotive. And I would like, to be honest, to share with you this journey. I hope you enjoy with this. So this is the reason. This is the main topic, actually. It is how to create research, use the research, apply the research in public domain. So my topics today, I will starting with the science and the practice, science from university, practice from industry. Flow of not. Okay, can you please, if you don't mind, can I ask if someone just mute himself because there's quite background noise?
Okay, I will check.
There is a background noise, very background noise, because I could hear a lot. So yes, so I will start my topic with what's the difference between science and the practice, flow of knowledge generation, once we're starting to generate a knowledge, and the flow to transfer the knowledge from concept to application, learning factory. We need to focus on this word. This is really important terminology here, learning factory. And then I will talk about the case study and the recommendation. I cannot give a representation because I believe 100% all of us hear about and aware about bridging the gap between research and industry. Many even before I moved to UK in 2007 or 2006, always in my head, why is there a difference between what we study as a graduation, for example, graduate study, and what we should use to work in our life. So what's the problem? It's very clear. The problem is a poor connection between three pillars. What's the pillars? The pillars is actually the pillars of the economic development: university, industrial, government. Actually, if you see this graph, you see university is the orange one, industry is green, government is the blue. You can see the path. When I talk about the path, I talk about the roadmap of each sector, because each sector has a roadmap, and the roadmap as defined at a certain amount of years. Okay, the next 10 years we should focus in blah blah blah, and the next 10 years we will focus in this and this. So this is a roadmap. But actually, if you see the paths, it's very rarely to be connected. I mean, but even connected at quite late, at half of the roadmap, half of the path, or end of the path. But how we connect these three terminals together? And this is exactly the problem. So it means the research always in any country, but I don't need to talk about special cases. The researchers actually always call the industry, good industry, asking for a data collection. And I always attending seminars. I have been invited to attending seminars, master degree, PhD degree in our university in Helwan. This is my mother university. And it's always, I feel the points here. Oh, why you didn't apply this? I said, oh, doctor, we're always going to ask about the data, but we don't have a data, which is right. He's right. I'm not blaming him, the researchers. But this is a problem. So it means the researchers always, I believe, correct me if I'm wrong, and I'm very open for any criticism. The researcher is always open for search about the researching point, quite from internet. So when I ask a researcher, for example, when he do a seminar to starting his journey for his master degree or PhD, how you know this point? How you get it? Oh, from internet. I found different people doing this research, and I would like to learn, which is okay, but it is suitable as a learning process, learning as a researcher. For example, I'm always saying, master degree, you can use it as learning period of time. You just learn yourself how to be a researcher. And then your PhD, use different. Use your skills to research for something new, which has to be like this. So the problem is all the research points, there's the university, and then the government always asking, because the government has to put a strategy, the economic strategy. So the government put the strategy, talk to the industry. I need to have this. We need to apply this. And then the industry, he doesn't understand what you need, because there is a missing point here. How can, for example, I need to for example, new car, electric car like we did, which is fantastic, but industry is struggling to do this. So this is the reason we're maybe going to learn from other IP, purchase new IP, for example, from other sectors, from external resources. But yeah, and then what is university then? It can help, can interpret the requirement to industry. This is a sequence. So the objective, what's the objective? When you're doing the research, you need to know how to do the research and how to be used in the government and industry. This is the main point. When looking for a research, you have to look for a point that, don't you looking for a point is repeated for a long time. You, as we agreed, I believe you agreed, that the point, if you need to repeat another point from external, I don't like this, but can be learning a process, but not a research. And after that, you're exploring mechanism. You're sit down with the people from industry. Try to explain your product, your idea, your new service you can provide them. And you have to let them know, okay, with this service, you will have percentage of benefit, like percentage of cost increase, cost reduced, percentage of income, percentage of weight you reduce, performance. So you have to give numbers, not random numbers. Numbers come from the research output. That's it. So scientific research is the research performed in systematic and constructed scientific method, not random. Have to be smart the way to doing research. When I say smart, it's very simple. You can say S is a specific. So you need to determine exactly specific point, and you need to sort this, and you know what's the output at the end. You are very specific, define it in the new research. Okay, measurable. You have to put something like milestone and deliverable, actually. Milestone and deliverables. So for example, okay, my research, it will have main 6 milestones and also 7 deliverables. So you need to break down the scaling measuring of your research. So for example, making your objective measurable. Okay, to do this, I have number 1, get the data. From where? From testing. So number 1, you get testing. How you get the test? Number 1, I need to know the material. This is correct. Number 2, I need to know the method of testing. Good. Number 3, where I can perform the test. And then you get the data. This is the milestone and this deliverables. Achievable. Don't put something like not reliable. You can, for example, say, we can press this part. I'm a mechanical engineer, so please forgive me when I just drop some examples as a mechanical engineer. Okay, so I love to put some examples. This is so when you press the parts, for example, and they said, this part can be pressed or can be formed. This component of the car structure can be formed using 1,200 millimeter per second speed. This is not correct, actually. How can I get this specification of the press to give you this very fast speed? This is not reliable. You have to determine your process window based on the capability you have. So first, as an input, the capability of the press. Once you have the capability of the press, okay, work out about this window. And then you find it. We find kind of the optimum path and optimized parameter to form your part successfully. Relevant. This is really important. So you have to select correct person, correct things, correct tools, relevant tools to solve your breakdown segment of your research. Not, for example, I need to do thermal analysis. Okay, I can do with Excel, but I need to do a simulation. I can do an Excel. This is not relevant. It's something different. So you need to be sure. And of course, If you understand the point from the beginning, the specific, as I mentioned, you will know what exactly is the tool you use. Time-based, you have to put a time scale. This is all of us know that. So personally saying who and what is specific, measurable, as I mentioned, percent, how much, how achievable. You need to know the method, why you select this software. You need to ask yourself, why I should use this and what I should use. A very valid question, actually. Time-based. When I finish this work package number 1, work package number 2 for message, this is the way you perform your research in a smart format. Look, we talk about research and we talk about, so we go from academic, we talk about industry. Each one of them has a goal, its own goal. So for example, academic research, we need to be, I will be frank with you. What is academic research objective or goals, aims in his working? Personal development. I need to be a professor. Correct? Yes. And I need to be a dean of the college, president of the university. This is fantastic, no problem. Published in academic journal. We are here in a conference, international conference. So all of us keen to attend this, do some paper, published, raise your scale, raise your H index. This is important, to be honest. Generally, have long time for publication. We don't have quite, you are flexible in your work to determine, oh, I can do this, I can do this, I can do this. Industry, no. Industry, he will say, I'm working as principal technical in automotive manufacturing company in UK. So I'm industrial man, and also I'm academic. So I know the difference. Industry, he will say exactly, I don't care about your research. I need a specific solution of my problem. Do what you need to do. I give you example. One of the project, I was in a big customer, very, mega scale customer. Is a tier 1, is big here in UK. And I was starting my the project, and my boss introduced me, and he said, oh, this is Dr. Mohamed from Imperial College London. Imperial College is quite well known in UK and over the world. And the guy from the industry said, oh, good, nice to meet you, Mohammed. Mohammed, we need a part, not a chart. انا عايز منتج مش عايز خريطه. انا اسف يعني بس انا افتكرت كده. We need a part, not a chart. So I have to answer this. I said to him, oh, it's okay. I will give you a part with a chart. This is the answer. So we now know there is a problem. We know there is a problem. Okay, but imagine what's the difference between the science and the practice. Engineering science and engineering practice. So you can find, actually, this is happening with my student, actually. One of the students can have excellent degree. And maybe he's the first in his class. First. Brilliant guy. And then he does interview. Super fantastic. The guy, interviewer, said, oh, you are very knowledgeable. Well done. We give you offer, give you a job. Unfortunately, when he just starting his practical life, the first test he facing in his life, he will fail miserably. By the way, mechanical engineering boss is the toughest boss, very tough in all the world. UK, Germany, mechanical engineering boss is really tough. So he will not give you a tolerance at all. This is the problem. Why? He is excellent guy, he excellent student, graduate. Because he always basically depend on how he has skills to know the information and has skills to solve the exam. But it's not his problem. Yeah, sometimes academic festival. You can see very classic very classic way to teaching the students. Even for undergraduate, postgraduate, the curriculum is really old. I believe, to be honest, it's quite old, the classic curriculum. And as I mentioned, this is give miscommunication between the government and industry. And you can see the fresh guy. Really poor. It's not, when I say poor, it's not a big, it's not bad problem, it's not bad ticket for him. No, he can, what he can do. This is a problem. So this is the learning factor we're talking about. People think, this is very famous, actually, in the internet, search it. There is people searching, oh, we need to connect this. Okay, and instead to have triple helix model, we should have learning factory. So we have a learning association to connect all these three together. So what the university government do? Identify the industrial need based on the strategy. They put the strategy, defining industrial strategy. And then the industry said, oh, okay, but I'm sorry, how can I do this? I'm industry man, so I need a process. I need a new technique. So he has to come to university. And university, to solve this, probably we need to have balance between the engineering science and the practice, and also develop it properly. Will need to develop new curriculum and the study program. Why not? This happened in Imperial College and Cambridge. Changing the curriculum. There is now, yeah, in 2 minutes I will let you know. There is a new course, new module. It's called lightweight technology material. This wasn't there before. No. Look at the rule of the government. So UK is, as I mentioned, no research can be on a shelf. Has to be, has objective and outcome to be implemented. So the government said, oh, I need to strengthen this. I need to add another push to transfer the research to the industry. Look what's he thinking about that. They establish a kind of Catapult Network. Catapult Network have 7 centers: AFRC, advanced forming, composite, machining, and so on. Digital manufacturing, nuclear, MTC. So establish dedicated or research-oriented for different manufacturing divisions, for example. And they put it all in the UK. You can see they spread it out to all UK. There one FRC in Scotland, Newcastle, Birmingham, West Midlands, Cardiff. So put it all of these, and each one of them has connection established by university, like a spin-off. He will not responsible for teaching. No, he doing all the research with high capability, with funding from all the industry. So the people saying the industry come quickly if you have a problem of forming to the AFRC, come quickly for machining and so on. This is Catapult is a name of network of new technology and innovation centers designed to transform a great research rapidly into the commercial. We need to increase this. Actually, is a university doing this? Each university has an office. It's called Tech Office to transfer the knowledge. And then you can see a lot of fundings. We'll not talk about this because in Egypt we have also a lot of funding bodies here to funding researches. But you can see this one is, for example, arts, humanity, biotechnology, economic, and what is engineering? This is on engineering. And this is, you can apply for a project and studying the project. If they see is visible, has impact, they will give you a fund, no problem. What is the cycle for this? Research commercialization. This is the main point here. Look, starting research. This is the cycle I have been involved, to be honest. Research, create a novel technology. I called, for example, our technology is HFQ, hot forming and cold die quench. I'm quite worried about the time. I'm sorry, Dr. Nouby. I will try to finish as soon as possible. So invention disclosure. Oh, go to the Office of Research Commercialization. It's called Imperial Tech. See the visibility of this. No one did before. Do assessment, protection needs, commercialization opportunity is okay. Oh, it's fine. Yes, there is a process and there is a chance to have a patent. File the patent, finish. Marketing. After marketing, you're own actually you try to open your own business as a university. Licensing, you can give it. If you cannot open a factory, you can license it. So you can buy, you can sell the license to other OEMs. Tiers 1, tier 2. When I'm talking about tier 1, tier 2, it is company scales, and then commercializing gets the benefit. This is a cycle, innovation cycle, and this is all the universities, high-skill universities, the top universities have to follow these cycles. Okay, this example. This example, I need to talk about it. In Imperial, just when I starting my PhD, saying, oh, there is a problem about the pollution, emission, and they discover that, okay, the pollution comes from the transportation, you can see. So the government put the strategy, as I mentioned, put the strategy and said, oh, we have to reduce emission. That's it. If you cannot do this, as even you are a big company, you will close, doesn't matter. Strong. And then saying, okay, we have to reduce the emission. And people think, how to reduce emission? How to reduce this? Oh, you need to reduce the weight of the car, because when the car is heavy, so the fuel consumption is high, and then the emission will be high. So the researchers thinking there is a problem. The people, the government need to reduce emission, and the industry is asking the automotive manufacturer to reduce the weight of the car. So it means they have to replace heavy metals with lightweight metals. And they discover this. Once the car increase, the emissions increase. And once the car increase, so you cannot get more benefit from the fuel. So you can see, you can have vehicle mass, it's increased, but kilometer, you can have just only kilometer per liter like this. It's very, very small. So they think about this, okay, weight reduction has a benefit, has a future, fuel economy, environment aspects, improved performance of the car, which is known, saving costs. And this is the flow. The flow of knowledge generation. So starting from the concept, the research, university, until going to industry. Apologize if I put some photos. I'm not mean anything here. I'm not showing up, but just to show the flow of create the knowledge until we have a new product. Okay. So for example, starting here, research knowledge generation, you can look into office, read a lot of the process, how to form this, how to form it. So I need to know the knowledge about this material. I have a lot of hair here, but unfortunately now I lost because I working very hard. And then go to the lab. So go to the lab, doing the experimental, determine the process window to know if this process can be visible for small scale. Yes, we found it. It's small scale, working out. It's good. The university sent me out as knowledge transfer, sent me out as industrial secondment, like إعارة صناعية. Spent 1 year in very, very, antiques companies called Lotus, very old, but it's really, really, really famous, Lotus car. I spent 1 year in the company to implement the first part, the process in the first part. After that, oh, we have the first part. You can see the parts here. The university asked me to attend all the conferences, Spain, Germany, Italy, Greece, all the conference, because I need to commercialize the process. I show the people, disclose the things. Okay, we have a process, we have a product. Until now, we have, present. Now we have a company. Not me. I'm a principal technical in the company. Company is belong to Imperial. So this is a flow. If you talk about research knowledge generation, if you break this, here you go. Here you go. This is the research, pure research. Okay, doing test, creating a damage model, viscoplastic damage model, testing, material testing, tensile test at different temperature, different rate, deforming the process window. This is the process window. I said, oh, here is the process window. This is the area. Speed, is this the speed we should working on? Really? Yes. And then this is at Imperial Lab. Then we'll try with small scale. The guys come to us, said, oh, can you do this in your process? We hear that you can have a knowledge in this process for aluminium. Can you do this? Okay, like us, it's called doing a stiffener. And this part, actually, the customer was doing this part machining. Imagine big part, not small like this is a scale. Big part is machined to this thickness. Imagine how much material is wasted. But you can see, form it. And these two students here with me, working fine. Go to Lotus, do the process with whole part. You can see if you form it with previous method, splitting. It's not, it cannot be formed. But with the process, form it successfully. So now we have a case study. We have this place, it's called Impression Technology, and I'm a part of the team. It's a spin-off company from Imperial, as I mentioned, and this is in Coventry. And we have now customer from automotive, aerospace, rail, mass transit. So we have cost reduction, mass reduction. People think about this. The industrial people, very clever to think about these 3 points: cost reduction, mass reduction, design flexibility. Oh, really? You can achieve this? Oh, yes, of course. Oh, no, can we have a meeting? That's it. And this is just a small video to show the process for the A pillar of the car. So he takes the plank from the furnace, heats the part, takes the robot, take it from the plank, and then move it quickly to the press for forming. Form it. Another part is becomes mass production. This part is in Aston Martin car. And we have many parts now. We have 25 different HFQ hot forming and cold die quench in Aston Martin DB11. We have commercial production line, as I mentioned, in Coventry, in UK. Nearly 100,000 production parts per year in 2020, and now it's increased. So you can see the parts. Just example, you see complexity of the structure. The guys from automotive manufacturers, when you see this component like this, oh, this is really important to us because it will integrate many parts together. So it means you eliminate the joining, eliminate other process, eliminate tools. And another one quickly, this is the last one. I'm sorry, take a lot of time. You can see this is the DB11. This is the A pillar, header, P pillar, B pillar top, and B pillar and cantrail, the cantrail. Yeah, this is structure and the B pillar outer, and even the door as well. The door comes from aluminium now. Even the door beam, the door beam is for crash, yes. And dashboard, this is to protect the driver. And recently for electric car, we're doing the battery as well. So I'm not advertising my work here. I'm just telling you what is the technology, and how it is transferred from university to industry. Last slide here is after that, we have a partners. We sell the license. We have a line in Germany, China, US. So I'm traveling all these partners to train them about the process. I just came from Germany. Next month, I will be in the state. So we train the people about new technology. Okay, I think I finish, and I hope I can give you, because it's a big topic. It takes a long time to talk about it. Yeah, but I'm constrained with the time, and thank you so much. And I'm happy for any question. Thank you.
Thank you so much, Professor Dr. Mohamed Saad, for the very interesting and valuable keynotes about how to bridge the gap between academic research and industry. Once again, thank you so much.
Yeah, and thank you, and I'm happy if any questions.
We have a couple of minutes for questions. To
Yeah, please, yeah.
Any questions?